Now, we want to look at general review of set theory. Set theory. Now, I've done a class on that set, and you should be aware of that. So you should look at that class and be happy. But I just want to do a little paraphrasing or an overview again on the set, mainly algebraic set notation and some other important things in set. Now, set is just, we said, it's a collection of data or numbers that can either be the element or members of the set. Now, we can present a set. For example, if I have something like this, if I want to present a set, let me say I want to collect the data which are just numerals, whole numbers from maybe 5 to 7, just whole numbers from 5 to 7. So I have 5, 6, 7. So this is not a set yet. So sets like this, which is just elements inside, they are just 5 to 7. We are collecting numbers, whole numbers from 5 to 7. So before I write a set, I must enclose it with a curly bracket or braces. So this will make it to be a set. So this set of 5, 6, and what? And 7. So there's another way I can write this. So that you see it, I can write it this way. X such that I will forever say X belongs to. Okay, before I do this, let me quickly first explain something. So just keep this in mind. Keep that in mind. Now, there are some things you are going to something like on that you have to understand in set, which are the set notations. For example, if you say something like this in set, it means such that. Even though you're also seeing something like this, it also contains such that. It means such that. Then if you say something like this, it means member or element. It means it belongs to this. Yeah, it belongs to this group. For example, now you should know the meaning of integers, you should know the meaning of whole numbers, you should know the meaning of natural numbers. It's very, very, very. If you don't know the meaning of whole numbers, natural numbers, integers, please go and research on them. Then try and look. Because I don't want this video to be too long, so I cannot be explaining those ones now. You can go and look at the first videos, the first set video I did because of that, because that one was a very long class. But I don't want this class to be long at all. So this means elements. So if I want to write something like this now, I can say A is equal to X slash X E W. Now this one means A is a set of X, A is a set of X such that S is a member of whole numbers. That's what I mean by that. So please take note of that. It's very, very important. Then I want to write X is between 5 and 6. I'll just say for 5 is less than or equal to X and S is less than or equal to 7. That this one, it means S is between 5 and 7. And both 5 and 7 will be involved because 5 is less than or equal to X. So you said that if S is either, for example, now, if I'm telling you that 5 is less than X, it means that X is greater than 5. That is what I mean. If I say 5 is less than or equal to S, it means that S is greater than or equal to 5. That's another way to write it. If you want to write this S first before 5, if you want to interchange it, you return this one. That's what I mean by that. So please take note of that. It's also very, very important. So this is what we call algebraic set notation. If you watch the first video, this one will not be a problem to you again. So if I want to write this one out now, I'll just say A is equals to a set of X, sorry about that bracket, and S is a whole number between 5 and 7. I just write 5, 6, 7 because both of them are inclusive because of this equal to sign. That's with this greater than or less than. So please take note of that. It's very, very important. It's very, very what? Important. Now I can also look at something. You look at type of numbers. Look at type of numbers like all those prime numbers, multiples, factors, and others. I can be doing factors now. I can be doing factors is just something that can divide another thing exactly without a remainder. Multiples means, for example, all these things you multiply. For example, 2 times 1, 2, 2 times 2, 4, all those 6, 8, something you multiply with 2, and so you're going to get, those are multiples of 2. 2 times 4, 8, 2 times 5, 10, those are multiples of 2. So you take note of that, it's very, very important. So these are just notations that we use in set. And remember, we have union set, intersection set from the other video. For example, if I say I have A is equals to, let's say 3, 4, 6, and B is equals to, let's say 3, 4, 9. If I ask what is A union B, it means 3, 4, 6, 9. It means join everything here, just combine everything here, but don't repeat any one 2 times. That's the meaning. If I ask what is A intersection B, this one means something that is in A and is also in B. That's the meaning of that one. You see, 6 is here, 6 is not here, 9 is here, 9 is not here. So that does not intersect. So you just pick only 3 and 4 from that intersection set. So this one is intersection, this one is union. Union means combine the two together. What is in A? Combination of both element of A and element of what? B. So those are intersection set. Now we also have power set. We also have power set. Now, which one is power set? So let me just quickly use something nice to explain this intersection. For example, now if I say A intersection B, it means a set of element of A that are also in something like in B. That is the meaning of that intersection. A set of the elements in A that are also in B. So element of A and B, that is no, it's not just element. It's not when you combine elements of A and B. No. It means elements present in A and also present in B. That's the meaning of that. So you please take note of that. Union means A union B means, okay, let me leave that. A union B means elements both in A and B. I can just say both A or B. Element in A or B. You can also do it like that. So union means A or B. Intersection means A and B. It is in A and is also in B. That's intersection. Elements in A and is also in what? In B. Then if I say union, it means element in A or element in B. That is union. So please take note of that. It's also very, very important. We also have power set. Remember I said I don't want this class to be long. Also have power set. Now, which one is power set? Power set is just something like, let's say, power set of A. It means all the subsets. Subset means set extracted from a bigger set. That's meaning of subset. So if I say A is equals to something like this, so I say A is equals to 1, 4. If I now say what is the power set of A? It means all the little sets I'm going to form out of this place. That is the meaning of power set. And what is the meaning of that? It means okay, let's see the little set I'm going to obtain from that place. So I'm going to obtain something like, I'm going to obtain a set of 1. Then I'll obtain a set of 4. See, 4 is from this place, 1 is from this place. Then I'm going to obtain a set of 1 and 4. They're also from that place. Then I'm going to obtain an empty set. So empty set is always a subset of all sets in this word. So please take note of that. It's also very, very important. So you check this power set now. Look at the meaning. Look at this is how to form power set. Just form little set from this full set. So I'm going to have 1 first, which is this. Then I have 4, which is this. Then I have 1 and 4 together, which is this. Then I have empty set, which is also here, but you cannot see it. So that's how we do for power set. Now, is 4 sets. The power set is 4. And how do you know? Look how to know. Power set of a set means power set of a set means 2 raised power n. That's how to get it, 2 raised power n. Now what is this n? N means the cardinality or numbers of elements of that particular set. So if I say power set of A now, I say power set of A, it means 2 raised power. How many elements are inside A? We have 1, 2. We have 2 elements inside that place. So 2 raised power 2, which is what? 4. We have 4 power sets of this place, which is 1, 2, 3, 4. So that's the power set of that. All the subsets of this particular set A. If I ask you now, what is the power set of this? Let's see, A1, B4, A1, B3. What is the power set of this one? You are going to have, we have, how many elements do we have? 1, 2, 3, 4. We have 4 elements inside. So the power set is going to be something like 2 raised power 4, which is 16. Are we? Yeah. 2 times 2 times 2. The power set will be 2 raised power n. How many? N means number of elements here. Cardinality, that's 2 raised power 4. We have 4 elements there. So I'm going to have 16 power sets. Now to list out the power set, what you just have to do, to start, we have set of A. Then we have set of 1. From this place, just pick up, just be arranging. We have set of B. Then we have set of 3. We have set of 3. Remember, we are going to have empty sets. Let me just write that one out. Then we have set of space will be enough. We have set of A and 1. Then we have set of A and B. A and B. Then we have set of A and 3. Then we have set of 1 and B. Then we have set of 1 and 3. Then we have set of okay, B and 3. A and 3. Just don't be doing combination. Then we have set of, but don't repeat something twice. That is the major thing there. We have set of A, 1 and B. We have set of A, 1 and 3. See, I'm talking about space just now. Let me see if I can clean up some spaces. Remember, we're looking for 16. Remember, we're looking for 16 subsets. Don't forget that. Then we have a set of something like we have a set of A. Okay, let me not include this. Let me just leave this one so that you don't say okay. Let me just be writing C. So I've done A1 and 3, A1 and B, then 1, B and 3. Then we have a set of everything which is A, 1, B, 3. So you count to see if it's up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15. So it's not up to 16 yet. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we have one set left that we have not included. So let me look for that and put it. So if you check very well, you discover that there's one we did not add. That one is A, B, 3. Now that one was not included. So you count again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So those are the subsets. These are to bring out the subsets of this particular set. So that's how you do for set. What about Venn diagram? Okay, let me go look at lots of sets. The video is already getting much. Now the first law I'm going to look at here is the identity law. Idempotent law, not identity. The idempotent law. Now which one is idempotent law? Now if you have A intersection A, it will give you A. And if you have A union A, it will also give you A. This is what we call idempotent law. Then we also have associative law. You can look at that. We have commutative law. You can look at that. Commutative just means, for example, now A union B is simply as B union A. Whether you interchange A intersection B, simply as B intersection A. So that is commutative law. So we have distributive law. You can look at that. Distributive means you can use something to open a bracket. You can also look at that from your books. I will not be explaining everything. Then we have identity law. We have identity law. Now, which one is identity law? If you have A union empty set, the answer will becomes A. And if you have A intersection empty set, the answer will become an empty set. This is what we call identity law. That's what we call this one, identity law. Now, if you do something like this, there's another one. There's another identity law you have to know, which is something from this A intersection union set. If you do A intersection union set, you are going to have A. If you do A union, no, if you do A intersection universal set, not union set, universal set. If you do A intersection universal set, the answer will be A. If you do A union universal set, the answer will be universal set. So please take note of that. It's also very, very important. So if you do A union empty set, A intersection empty set, A intersection universal set, A union universal set, give you universal set. Then we also have the one we call evolution law. Evolution what? Law. Number one of this law is that if you have A complement, the complement of A will give you back A. This one is what called evolution law. Then it's just something like work with some motion complement. If you have A union A complement, the answer becomes the universal set. Then if you have A intersection A complement, it become an empty set. A complement become an empty set. Now, if you don't know the meaning of complement of a set, it means elements that are not present in this set, but they are inside the universal set. That's what we call the complement of that set. You can check the first. This one is just a general overview of the sets I did before. So take note of that. It's very, very important. Then we have another law, which is the complement law. The complement law. Now, one of this is that if you have the complement of universal set, it become an empty set, while the complement of an empty set becomes the universal set. So that's this one we called the complementary law. Now, how do you multiply set, which is the product of a set? Product of a set. All right, now let's look at just a question on that. This, if I have A to be equal to this, if I have A to be equal to 1, 2, 3, 1, 2, 3, if I to be equal to 1, 2, 3, then B to be equal to 3, 4. I can ask, what is A times B? Just try and get this once and for all. What is A times B? Now, A times B will be, you pick 1, you pick this. Just like you're opening the bracket, you just want to multiply this. 1 to multiply 4, 2 to multiply this, 2 to multiply 4, 3 to multiply this, 3 to multiply 4. So if you pick 1 and 3, you're going to have 1, 3, we have 1, 3. Then if you pick 1 and 4, pick 1, pick 4, you're going to have 1, 4. Then if you pick go to the next one, 2 and 3, you pick 2, 3. Next one you pick 2, you pick 4. You're going to have 2, 4. Then 3 3 and 3, then 3 and 4, 3 and 4. So this is how you do product of a set. Pick this, this, just like this one, this one, this one, this one, this one, this one again, this one, this one, this one, this one again, this one, this one. Just that is just how you do it. So that's how we do product of a set. Now we can also ask you what is let's say a square. What is a square? A square means a times a. That is a square. Let's of a square. A times a. You use a to multiply a. That's what I'm going to get as a square. For example, if I say a square, just 1 and 1. If I assume we have a square, now will be 1, 2, 3 times 1, 2, 3. That's 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3, 3 and 1, 2 and something like that. That's what I'm going to have. Okay, let me just quickly use a little one to just, if I have a to be equal to 1, 2. Let me write this thing well. Because to write it is not actually that easy. Just gotta manage. So I have sophisticated board here. Now, if I see what is a squared means a times a, which is this one times another one times another, which is 1 and 2 again. Pick 1 and 1. You have 1, 1, then 1 and 2, 1, 2, 2 and 1, 2, 1, then 2 and 2, 2, 2. So that's what I'm going to have as your a square. A cube means a times a times a. Add another one to it. 1 and 2. So pick 1, 1, 1, 1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 1, 2, 2, 2, 2, something like that. That's what I'm going to have. So please just try and look at your books under this product of a set, because I don't want this class to be long. It's already getting too long. Now let's move to just Venn diagram. I've already done Venn diagram. Let me just look at 1 or 2 examples under that. Then I'm done with this class. Now, Venn diagrams is just like a graphical representation of sets. I've already done that in a video. Let me just do 1 or 2 so I see it. For example, let's say we have a class. Let's say we have a class of total student 40. And inside of this student, okay, let me use subject chem. 25 students offered chemistry, then PHY, that's physics. 30 students offered physics. Now if you add this, and the total student is 40, if you add these two things together, you're going to have a number more than 40. I think I'm having 55 already. See, this is 55 total, but the total student is 40. Now what's the meaning of this one? Does it mean that the question is not correct? No. This shows that there are some students doing both of the two subjects. That's why it's more than the total number. That is the meaning of that. So for you to get the number of students doing both subjects now, you can only use a Venn diagram. You can use Venn diagram and you just get everything in a very simple way. How do you use that? Look how to do it. What you do, you draw something like this, which is a square or a rectangle. You draw a rectangle, because I may not solve much questions of this because of this little board I'm using. Then you draw the first cycle. Draw a cycle. Now remember the total number of chemistry students. 25. Is it 25? That's 25. The total number of physics students is 30. Now remember there are some students doing both. That's why you don't just come and put for chemistry. If you see this one is for chemistry, can I just come there and put 25, because chemistry is not 25 only, and this box here is for chemistry only. So you wait first, then you draw another one to it, and this one will be for, I'm coming, let me draw a bigger shape. Everything is supposed to be inside. This is supposed to be inside. total number, which is the universal set, 40. And now this place now, this intersection point, that's where both of them, this x are the student doing both. So your where is there? Because you don't know student doing both. Now what about student doing, if I say this one is for chemistry and this other one is for physics. Now student doing chemistry will now be that 25, which is total, minus x, which is for student doing both. Student doing physics will be the total physics, which is 30, minus x, which is for people doing both. So that will be 30 minus x. So that's what I'm going to have. And remember, everything is 40. All the students, they are 40 students. So we are just going to do add everything inside this bracket, inside this rectangle together, add everything together, and equate it to this, equate it to 40, because it should not be more than 40. So you're going to do something like this. You're going to do something like this. You're going to do 25 minus x plus x plus 30 minus s must be equal to 40. Must be equal to 40. So minus s plus s will go. This plus this one, we are going to have 55 minus x is equals to 40. So you move this one to this side, and you move 40 to this other side. We're going to have 55 minus 40 is equals to x. So s, which is student doing both, will now be 55 minus 40, which is 15. So we have 15 students doing both physics and chemistry. Okay, how many students are not doing just chemistry only? How many students are doing just only chemistry? It will be the total number of students, which is 25, minus students doing both, which is 10 students doing only chemistry. And what about students doing only physics? 30 minus students doing both, which is 30 minus 15. 15 students doing something like offered only physics, just physics only, without any other subject. Now, there's another question here, which is something like this. They said in a sample of 80 cars owners, reveal that 24 owns Jeeps and 62 owns cars which are not Jeeps. Find the number of people who owns both a Jeep and some other cars. Something like that. In the sample of, look at this. If we use a rectangle to represent that sample, sorry about this. If we use a rectangle to represent that sample, something like this. He said the total number, we have 80 cars owners. Now they said in this 80 cars owner, 24 owns Jeep. 24 owns Jeep, and 62 owns cars which are not Jeeps. They are not Jeeps. So we also have some people there, not Jeeps. So we may use J prime, and that is 62. So remember, we have, how many cars owners do we have there? We have 80 cars owned. Example of 80 cars owned, we read that 24 owns Jeeps and 62 owns cars which are not Jeep. Actually, is cars owners. They are cars owners. We have 80 cars owners standing. Out of this 80, 24 owns Jeeps, 62 owns cars that are not Jeeps. Now let me first of all add these cars owners inside this place together to see what we are going to have. That would be very, very nice to do. So let's add to see what we're going to have. Now add, let's see. 24 plus 62. I think that is going to give us 60 watts. That's going to give us something like 80, 86. That's what we are going to have. We're going to have 86. This shows this is even more than this. You see, you have people that own cars. You have people that are something like here. They own both cars. So that is what we are looking for. They say look for those people that owns a Jeep and some other cars. Yes, all those cars that are not Jeep. Somebody that will own a Jeep and a car that is not a Jeep. So we have 62 owning cars that are not Jeeps. We have 24 owning Jeeps. And there are people owning both cars that are not Jeep and Jeep. So they will be here. They own both. Then this one will now be 62 minus those owning both. This one will be 24 minus those owning having the boats. So what you just do, add everything together, 24 minus x plus x plus 62 minus s, everything will be 80. So next thing, s cancel x, this plus this, you're going to have 86 minus x is equals to 80, and s in this place is going to be 86 minus 80. So s is going to be 6. So we have 6 persons that owns cars that are Jeeps and other cars. We have 6 of them in this place. Look at another question. I hope you understand this. It's very simple to understand. Now